Welcome back again. We are still continuing with our question paper and we are now in question number 10. They say the picture below it shows a lazy Susan turntable that you need to build for your civil technology practical examination. A turntable rotates at 45 revolutions per minute. Now the first question is write down the rotational frequency in revolutions per second. You are given 45 revolutions per minute. So when you convert them, you take 45 and then you divide it by 60. You put that in your calculator, it is going to give you 0.75. That is a conversion from revolutions per minute to revolutions per second. They say determine the circumferential velocity in meters per second of the lazy Susan turntable if the diameter is given to you by 140 centimeters. First, the formula that we are going to use is pi multiplied by d multiplied by n, where d it represents our diameter here. And then our diameter is given by 140 centimeters. They want us to calculate everything in meters per second. So we're going to convert this 140 centimeters to meters per second. So first, our diameter is going to be 140 centimeters, and then we're going to divide this by 100, and then in meters it's going to be 1,4 meters. Once we have our diameter in meters, then we can substitute into the formula. Therefore, V, it is equals to pi, it's a constant. D, we just converted it to 1.4. And then the number of revolutions. In this case, it was 45 revolutions per minute. We converted that to per second, which is going to be 0.75 as substitution, making your V to be equals to 3,30 meters per second. That is your circumferential velocity in meters per second. The next question, 10.1.3, they say determine the length of the chord DE if the height is 25 centimeters and the diameter it is 140 centimeters. Okay, let's identify the DE. DE is this one here. That is our DE, and all we are given the height and the diameter as well is given. So the formula that we are going to use is 4h squared minus 4dh plus x squared. All of this equals to 0, where x represents what? The length of the chord. H is given as 25 and d is given as 140. So you're just going to substitute. H, it is 25, don't forget to square, minus 4, d is 140, h is 25 plus x squared. All of this, it is equal to 0. If you simplify, you're going to find that your x squared, this whole thing here, when you put it in your calculator, it is going to give us 11500. All of this, it is equal to 0. When you simplify this, it's going to give you negative 11500. And then we are looking for x, which is 11500, and then you take the root on both sides. You take the root on also on this side, and then you get that the length of the chord it is 107,24 centimeters. That is the length of your chord DE. You can finalize it and say that D is 107,24. It's still fine. Whether you leave it here or you leave it here, it's still okay. And then 10.2.1, convert the angle. Okay, let's read the statement. The picture below, it shows a discus circle in your school with the center O. The length of the diameter is 2.5 meters and AOB it is 34,92. All right. Convert the angle AOB into radians. 34,92, the angle in question is this one. We have to convert it to radians. So it's very simple. AOB, it is equals to the angle that is given, 34,92, degrees. When you're converting from degrees to radians, you simply multiply by pi and then you divide by 180 degrees. And then you put that in your calculator, you will find 0.609 radians. So that is our converted angle from degrees to radians. And then let's clear this. Determine the area of the minor sector AOB. The area of the minor sector AOB is this one here. The area in question is this one. All right. Now, what is the formula to calculate the area of the minor sector? The area that is given, the formula is pi multiplied by theta, and then you divide by 2. Okay, so what do we need to know? We need to know our radius. So how do we find the radius? We are given the diameter here. A diameter is given as 2.5 meters. So we know that a diameter, when you divide it by 2, you get what? You get the radius. So we're going to divide the diameter by 2. So we're going to take 2,5 and then divide that by 2 so that we can get our radius, making our radius to be 1.25. It's going to be 1.25. And then we can go back and substitute into our formula there. So A is equals to the radius is 1.25 to the exponent of 2. And then what is our angle here? Our angle is this one, 34,92, but not in degrees. We're going to substitute it in radians. So our substitution is going to be 0,609. The angle we calculated previously is the one we're going to substitute here, and then we divide everything by 2. Then you put it in your calculator, you are going to have 0,47. Since this is the area, we're just going to say 0,47 units squared. And that brings us to the end of question number 10. Let's see what we can do with question number 11. See you in the next segment.